Hello, Algebra 2 people. Before we completely leave Chapter 3 and go on to Chapter 4, I thought we should at least talk about matrices because it's going to be your only exposure to them. And you might actually like to know about them at some point in time. There may even be some questions on your SAT that talk about matrices. So let's just cover some basic information about matrices. It's a scary word, but it's really just a table of numbers. And this is the way we write a matrix. We label them with capital letters. So, for example, this is matrix A. That's its name. And we're saying that matrix A is equal to this table of numbers. And we put these little brackets, these square brackets, around the matrix to let people know that that's the matrix itself. Now, just like in a spreadsheet or any table of values, there are rows and there are columns. And this particular matrix has two rows. Rows go across. So there is one row here and one row here. There's two rows in this matrix. Columns go up and down. So there's one column, two columns, three columns here. And that gives us the size of the matrix. We say that for its size, matrix A is a 2 by 3 because we always list things in row by column. So one of the things that you'll be asked, like in your homework, is, what's the size of this matrix? And all you have to do is, count. How many rows does it have? This one has 2. How many columns does it have? This one has 3. Therefore, it's a 2 by 3. I always remember which one comes first because I used to like the POP RC, which stands for Royal Crown Cola. But that always in my mind tells me that it's rows first and then columns. So count your rows, put them first, and then count your columns, and they go there. Okay? Okay. We can talk about the numbers that are inside the matrix and refer to them by their positions. So, for example, if I said, what number is in A1, 2, I'm not talking about position 12. I'm talking about first row, second column. So the thing that's in A12 is 4. It's in the first row, second column. So A12 is equal to 4. It's just talking about the number that's in row 1, column 2. And again, you can remember which one comes first. RC Pop, Royal Crown Cola. What number then would be in position, let's say A21? Think about it. What does the 2 stand for? That stands for the row. What does the 1 stand for? That stands for the column. So A21 is actually going to be 6. It's in the second row in the first column. Here's row 2. And in that first column is the number 6. So A21 is the number 6. Okay? So matrix is a table of numbers. We name them with capital letters. We can tell their size by counting the rows and the columns and writing it as that size. We call this 2 by 3. It's a little 2 and then the cross symbol, like what we used to write multiplication. It's kind of like when you go to the lumber store and you're like, oh, I need a 2 by 4, 2 by 4. It's telling the size of the board that you need. In this case, it's telling us the size of matrix that it is. All right. Then quick review. We can talk about the individual, what are called elements. Those are the things that are inside the matrix. Each one of the numbers inside there is an element. By the way, this is not the number 241. It's three separate numbers, 2, 4, and 1. This is not the number 653. That is the number 6, the number 5, and the number 3. They are in different positions, and we call them the elements of the matrix, and we can specify individual elements by their row and column positions. Okay, moving on. Why would they have put matrices in this chapter? And the reason is because we can represent equations within a matrix. For example, if we had the equation x plus 3y is equal to 7, and the equation 3x plus y is equal to -8, we could write down just the coefficients, those are the numbers that come in front of the variables, into a matrix. So I can write the number 1, that's the coefficient in front of the x, the number 3, that's the number in front of the y, and then I'm going to draw a bar here because this is what's called an augmented matrix. That bar is kind of taking the place of the equal sign, and the last number of that then would be 7. So we're just writing this equation as a row in the matrix with the coefficients as the elements in that row. So 1x, 3y, and 7 is our constant. Notice that these are all in what's called standard form. Remember standard form of an equation where c is our constant term. So as long as we just have the constant on the right side of the equal sign, we can put that into the matrix. We'll do the same thing with the second equation here. The first element in that row is 3. The next element is 1. And finally, we can put -8 on the other side of this line to complete our augmented matrix. Now remember, matrices have these little square brackets that contain the table of numbers. So I can then put this system of equations into a matrix. That's the first step. And you're going to be asked to do that in your homework. They're just going to say, oh, you know what? Write that system of equations into a matrix. Anyways, and I don't know, I was trying to write a system of equations that maybe has some nice answers, and I don't know that this does, but let's go ahead and use the matrix to solve. And we do that by doing what are called row operations. And here's the thing. For any matrix, and this is really just, if I just look at the left-hand side here, it's just a 2x2 matrix, right? It's got 2 rows and 2 columns. And so if I were to look at what's called the identity matrix for a 2x2 matrix, it would look like this, where you have 1s on what's called the main diagonal, and everywhere else you have a 0. Let's suppose that I had a 3x3, and I'm not going to ask you to do any 3x3s. We could do 3x3s. This is where they would start to come in handy. But the identity matrix for a 3x3 would look like this. That would be called the identity matrix. There's a good reason that they're called the identity matrix, but for us, when we look at the augmented matrix, if I can get the main part of the augmented matrix as the identity matrix, then the numbers that'll be hanging out here to the right of that line actually end up being the solutions for our variables. Okay? If I can manipulate this matrix so that it looks like an identity matrix with a 1 here in this position and a 1 here in this position, and the other two positions there filled with zeros, and it's close. I mean, like right now, I have a 1 there and a 1 there. The problem is I got a 3 there and a 3 there instead of zeros, but um, we can do some row operations to make it look like this. But the idea behind this is that we're really going to be doing sort of the elimination method, but we're not writing any of the variables. We're just dealing with the coefficients, and that over time, when you get used to using matrices, makes it easier to solve systems of equations, especially once you start getting into longer and longer systems. It also makes it easier to do things like program computers to do these for us. But what we can do here is I'm going to leave row 1 alone. 1, 3, 7 still. Okay. But row 2, I'm actually going to do a -3 times row 1, and I'm going to add that to row 2. Okay. So I'm writing down here what I'm doing. If I multiplied the top row by -3, 1 times -3 is -3. And if I added -3 to 3, I'd get 0. Let me review what I just did. I took 1 times -3, but I got to add that then to the 3 that's in row 2. Okay? And then I'm going to take -3 times 3. That's going to give me -9, and add that to this number to give me -8. And then I'm going to take -3 times 7, and that gives me -21. And I add it to my -8, and that gives me like what, -29? Double check my math here. I did 1 times -3 plus 3 to get 0. I did -3 times 3 to give me -9, added that to 1 to give me -8. And I did -3 times 7 to give me -21, and added that to -8 to give me -29. Okay? Ugh, that looks really ugly. Why did I do that? Well, I'm trying to get 1s on the main diagonal, 0s everywhere else. It's a 2 by 2, so I need a 1 there and a 1 here. Notice that the other positions were filled with 3s, and I needed them to go to 0s. It is the elimination method. To get a 0 means that I've eliminated that, right? But these weren't eliminated, so I needed to get a 0 here, and I did. Now I just have to figure out how to get a 1 here. But before I do that, I'm going to have to get a 0 here, because it's okay to have a 1 there, but I need to get a 0 here. I need a 1 in the first slot. I need a 0 in the second slot. I need a 0 here. So how do I do row operations to get a 0 there? Well, I've got a -8. So I suppose I could multiply this times 8, right? And this one times 3, and add them together. So I'm going to write that down. I'm going to say, okay, I'm going to do 8 times row 1 and add that to 3 times row 2. Okay? So if I do 3 times row 1, or an 8 times row 1, I should say, I'm going to get an 8 And if I add that to 3 times 0, I still get 8. And then I'm going to come over here and go 8 times 3, which is 24, plus 3 times negative 8, which is negative 24, is going to give me 0. That's what I wanted. I wanted a 0 there. And 8 times 7 is going to give me 56. I might have to use my calculator. 8 times 7 is going to give me 56, but then I got to do 3 times negative 29 to give me 87. Which I think gives me negative 31. Again, that was 8 times 7 to give me 56, and 3 times negative 29 to give me negative 87. And you add those together and you get negative 31. I'm going to leave the bottom row by itself. I got 0, negative 8, and negative 29. Okay? Now, I'm close. I'm going to cross this off because that's a 3 by 3 and we're looking at a 2 by 2. I'm close. I need a 1 and a 0, and I have right now an 8 and a 0. And I need a 0 and a 1, and I have a 0 and a negative 8. Again, the thing I'm trying to do is eliminate. So even though we started off and there were 1s here, that wasn't going to help me. I needed to get these other positions to be 0s. And so now they are. And in order to make this a 1, all I really have to do is divide by 8. So I'm going to do my next step just by going, this is 1/8, or I'm dividing by 8 times R1. There's my row 1. 8 divided by 8 gives me 1. 0 divided by 8 gives me 0. There's my augmented piece. And then I have negative 31 divided by 8, which is going to give me negative 31/8, which is a totally ugly number. But that's what I get. And then I'm going to do the same thing here, but I'm going to divide by negative 8, or multiply by negative 1/8 times row 2. So 0 times negative 1/8 is going to give me 0. But this next one, when I take negative 8 times negative 1/8, I'm going to get a positive 1. Again, this is the matrix I'm looking for. And finally, I have negative 29 times negative 1/8 is going to give me 29/8. So that was an ugly problem. Hopefully the ones in your book are going to be more straightforward than that. But I guess it gives a little bit of a taste of what it looks like to do. All we're doing is really the elimination method. For any row operation, I can replace any row with any other row. Keep this in mind. I can replace any row with any other row. So if I wanted to switch this row and this row, I could just flip them, okay? They don't have to be, the one that's in the first slot doesn't have to stay in the first slot all the time. It can move down, and the other one can move up. So you can replace any row with any other row. Just rearrange them. That's one row operation you can do. I can multiply any row by any number. And that's what I did down here. I multiplied this row by 1/8 and just replaced it. Okay. So I can replace any row with a number times that row. Okay. Or I can add any multiple of any row to any multiple of another row, which is what we did up here. We said, oh, I'm going to take this first row, right? And I'm going to multiply by 8 and add it to 3 times this row and replace it. Take every number in this first row, multiply by 8, and add it to 3 times every number in this row. So 1 got multiplied by 8, and then I added it to 0 times 3. or 3 times 0. And then I came over here and I said, okay, I'm going to take 8 times 3, and I'm going to add that to 3 times negative 8, which gave me my 0. And then I came back up here and I said, okay, I'm going to take 7 times 8, which gave me 56, and I'm going to add that to 3 times negative 29, which was negative 87. And when I added those together, I got negative 31. So I just multiplied each number in the top row by 8 and added it to the corresponding numbers in the bottom row after I multiplied those by 3. So I can replace any row with a multiple of that row. That means I can multiply that by a number, added to any multiple of another row. So I was able to multiply the first row by 8, the second row by 3, add those together to replace that row. So think about my row operations. I can switch them, I can swap them. I can replace any row by a multiple of itself. That means I can multiply any number times that row and just replace it. And I can multiply that row by any number and add it to another row that's been multiplied by any number, okay? Those are the row operations I can do. And why am I doing them? Again, I'm trying to eliminate some of these so that they look like this. I need to get a 0 in the second position of the first row, and I need to get a 0 in the first position of the second row. And then I need to make sure that I have ones on what's called that main diagonal. So my first operation, my sole goal was to get a 0 in the first position of the second row. And my second goal was to get a 0 in the second position of the first row. That's my goal. Anytime I do this, the first thing I want to do is get a 0 in that first position of the second row. And the next thing I want to do is get a 0 in the second position of the first row. And after I've done that, I'm just going to try and get ones in these other spots. Okay? Ones on those main diagonals. These numbers just come along for the ride. Whatever you're left with in the end is going to be your answers. How does that work? Well, this really is the x position. Remember, when we were putting these in here, it was 1x plus 3y equals 7, and 3x plus y is equal to negative 8. So the things that were in the y position are in this second column. So what this says is that 1x equals negative 31/8. So that's my answer. X equals negative 31/8. And the thing that's in the y position says that 1y is equal to 29/8. So y equals 29/8. That gives you your answer. X is negative 31/8 and y is 29/8. If I was writing it as a point, it'd be negative 31/8, 29/8. So this is the answer to your system of equations. Okay? That's all that we're doing. If you look at the problems that you're assigned on page 179, the first thing to do is to say, recognize, and I'll put the book up here so you can see it, I guess. It just says, hey, what's in position A32? Well, look in row 3, column 2, and you see that there's a 7. So the answer for 8 is 7. It's just that easy. Then the second thing you're supposed to do here, oops, let me turn that off. The second thing you're supposed to do here is to write a matrix to represent each system. It doesn't say solve. So for 12 through 17, all you are doing is writing a matrix. Just like we did before, if your system says x plus 3y equals 7, you're going to write the numbers 1, 3, and 7 into a matrix. It's augmented, so you put a line where your equal sign would be, right? That's 1 from your x value, that's 3 from your y value, and that 7 goes on the other side of the line. Okay, you just do that for each equation. Each equation is its own line. That's just what you do. So you're talking 8 through 11, piece of cake, just figure out what the number is. 12 through 17, you're just writing these equations into a matrix, okay? Now for 18 through 23, you're just doing that backwards. It's giving you the coefficient for x, the coefficient for y, and the number that goes on the other side of the equal sign. So this really just is x equals 4. This row here is telling you y equals negative 6. This one says 5x plus y equals negative 3. This one says negative 2x plus 2y equals 4. You're just writing the equations from the matrix, okay? So think of that. I mean, 8 through 23, piece of cake. Now you get into, you're supposed to solve these, but notice that each of these is only a 2 by 2 matrix. So I'm not giving you 3 by 3 matrices to solve. You just have to plug these in for your row operations. And again, after you get that started, goal 1, get a 0 in the first position of row 2. After you've gotten that done, get a 0 in the second position of row 1. And after you've gotten that done, get 1s on what's called the main diagonal. You want a 1 here and a 1 here. And after you've done that, it's solved. That tells you x equals negative 31/8. This tells you y equals 29/8. It takes a little bit of getting used to. Wrap your head around it, but it's not hard. Okay? Okay. Look online to make sure you're doing the right questions. Good luck to you. If you have questions, email me. Okay? Good luck. We'll talk at you soon.